So good day everyone. So we're going to tackle about the maritime navigation radar. So we are the group 10. I am the cadet Swanner together with my group mates, the cadet Tabia, the cadet Chopi, and the cadet Omako. So the course outcome is the students should learn the history and importance of radar in navigation. The learning outcome are at the end of the session, the students shall be able to Number 1. Comprehend the history of maritime navigation radar. Number 2. Determine why radar is such a valuable tool. And number 3 is recognize the ship parameters. So the importance of the topic. So radar gives accurate information on distance from charted futures and assists in maintaining the ship's course. Radar will normally show a 6-meter high land mass at a range of 20 miles. This is considered by seafarers as a minimum requirement. So, history of radar. So, new technologies of radar became available to merchant shipping with the end of hostilities in 1945. Radar on merchant ships was initially installed for commercial purposes, like on ferries to maintain better schedules in fog and large fishing vessels. Radar was treated with great suspicion by the mariners. With improving technology, and after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction of the number of serious collisions at sea. International Conference on Safety of Life at Sea in 1960 revised the international regulations for preventing collision at sea by adding rules to take account of the use of radar and recommendations on the use of radar information as an aid to avoiding collisions at sea. The International Conference on Safety of Life at Sea in 1974 adopted provisions to the SOLAS Convention making radar a mandatory carriage requirement for merchant ships in the PACE program starting in 1980, which finally completed in 2002. So SOLAS requirements. All merchant ships of 300 gross tonnage and over now shall carry a radar and many carry two. IMO adopted performance standards for marine readers which are used in connection integration with other navigational equipment required to carry out board ships such as an automated target tracking aid, ARPA, EIS, ECDIS, GNSS, and others. In non-SOLAS ships, many small craft millions are also carry radar voluntary as manufacturers have produced cost-effective designs for their needs. So the shipmaster's point of view. So the key facts are the radar remains and will remain the primary system for collision avoidance. And number 2 is radar is a very important tool for navigation. So the next slide will be presented by Cadet Tabia.
Thank you, Cadet Soner. So for the following slides, we start with why is radar such a valuable tool? The master and watchkeepers have confidence in the information that the radar provides because its operation is ship-based. It is not reliant on third-party sources. It has a proven track record, and radar is useful with SARTs when engaged in search and rescue. In short, in its display, radar offers the watchkeepers the basic reality of all targets relative to the ship. It therefore aids the watchkeepers and helps in decision-making for both navigation and collision avoidance. Collision avoidance. Early action is required to avoid a close quarter situation, therefore early identification of closing targets is essential. Watchkeeping officers need to be competent in the use of radar and are trained in its use and the application of the ARPA. Some IMO requirements. Maximum emergency stopping distance from full speed of the ship should not be more than 15 ship's length. Emergency turn radius of the ship should not be more than 2.5 of the ship's length. Ship parameters. Speed is up to 25 knots. In length, the largest container ship is 335 meters. A Capesize bulk carrier is 300 meters. A Panamax 220 to 230 meters. Emergency stopping distance is 3.3 kilometers to 5 kilometers, or 1.8 nautical miles to 2.7 nautical miles. Emergency turning radius is 550 meters to 840 meters, or zero point 0.3 nautical miles to 0.45 nautical miles. Displacement weighs 100,000 to 250,000 tons. Practical requirements. To start plotting targets and determining their course and speed when the target is between 8 and 10 nautical miles off. Navigation. Radar gives accurate information on distance from charted features and assists in maintaining the ship's course. A radar will normally show a 60-meter high landmass at a range of 20 miles. This is considered by seafarers as a minimum requirement. So this is a picture, an example of a radar. It is in ground stabilized S-band. So we can notice the differences in its gain here for the next slide. Ground stabilized S-band. S-band is 2.9 to 3.1 gigahertz. It is to ensure that target detection and tracking capabilities are maintained in varying and adverse conditions of fog, rain, and sea clutter. So this is used in adverse conditions like fog, rain, and sea clutter. So this is what the radar usually looks like in a ground stabilized S-band. Next is a ground stabilized X-band. So we can see the differences in the gain and the sea clutter. From we can find the difference between the two, less gain and more sea color. So ground stabilized X band, it is 9.2 to 9.5 gigahertz. It is for high discrimination, good sensitivity, and tracking performance. So it is for the usual use X band, use only S band for adverse conditions. Next is the MSC 19279. So the MSC 19279 is adoption of the revised performance standards for radar equipment. It contains performance standard applicable to marine radars being produced and installed at different time periods in the past. Noting also that marine radars are used in connection/integration with other navigational equipment required to carry onboard ships, such as automatic tracking, target tracking aid, ARPA, AIS, ECDIS, and others. It is recognizing the need for unification of maritime radar standards in general, and in particular, for display and presentation of navigation-related information. So for the next slides, we have Cadet Chope.
So discrimination of targets from a watchkeeper's perspective. So to be able to distinguish a tag from its tow at sea at 12 miles range and approaching a rig on a supply vessel. So to clearly identify the standby boat from the rig at 6 miles range and to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range. So these are the examples of towing tugboats. As you can see in the screen, there are 3 examples of tugboats that they tow, such as buoys and rigs. So resolution MSC .19279. So range, what is range? The radar system should be capable of displaying 2-point targets on the same bearing separated by 40 miles in range as two distinct objects. And bearing, the radar system should be capable of displaying 2-point targets on the same range separated by 2.5 degrees in bearing as two distinct objects. So these are the examples. So as you can see in this radar, the range of the radar is 0.75 nautical miles with a bearing of 217.9 degrees. And also in this radar, it shows the VRM and the EBL to accumulate or to have a accurate position of a object. So what is navigation? Radar greatly assists navigation during poor visibility. pilots rely on radar at close range in reduced visibility to pass buoys and beacons. And this is also the example of radar. As you can see, radar is very effective during poor visibility, such as nighttime or bad weather. So as you can see, there's a lot of targets and objects near you, even if you can see in the visual or binoculars. And this page also shows the gain, rain, and sea clutters, so you can adjust it to maximize or minimize. Then this slide also, we adjusted the gain to the max, so that objects are very clear for us in the radar. Same as here, gain, we put it in the middle to be also clear enough.
So, thank you, Katichope. So, let's continue. Resolution is MC19279 for 5.4 minimum range, 5.4.1 with on shape at zero speed, an antenna height of 15 meters above the sea level, and in calm condition. The navigational buoy in table 2 should be detected at a minimum horizontal range of 40 meters from the antenna position and up to a range of 1 nautical mile, which without changing the setting of control functions other than the range scale selector. Next slide. In engineering terms, RES ITU-RM1313, power 30-70 kilowatts, horizontal beam width 0.75-4 degrees, pulse width 0.03-1 to 1.2 microseconds, PRF 4000-375 Hz, noise figure 3-8 decibel. Next slide. Antennae, pitch 3 degrees, roll 25 degrees, yaw 5 degrees. So vertical beam width 20 to 30 degrees. So this is the band radar. This is what it look like. So the X-ray band radar, that's what you see in the picture, and the Sierra band radar. Next. So this is the WP 8B report of November 3. It's a graph. Next. So this is the WP 8B 2001. As you can see in the picture. Next. This is the WP 8B 2001. So this is the radar now in the present time. This is what it look like. So you can see that the advancement of our technology, it improved our radar system. Next. So this is what the display of the radar now. It has a lot of features. Same. Next. That's all, and thank you.